Hi guys, it's Mr. T again, and today we're going to be talking about a little bit of an introduction to probability. Okay, probability, and we're going to and y'all know about probabilities, the chances of things to happen. So, what's the probability is the chance or likelihood of an event happening, and we can describe the probability using words from probability scale. And so we got all these different kinds of things, and you're familiar with probability to a certain degree. And but we're going to be kind of focusing on something called finding conditional probability using two-way tables. Okay, so depending on this situation, and then using a table, this condition, then what's the probability kind of deal. All right, so we got some examples here. Our first example is a college computer lab has 100 computers. Some of these computers are personal computers, PCs. Obviously, this is pretty old because y'all, the terminology is funny. And others are Macintoshes, Macs, okay? Um, some of the computers are new and others are used, okay? A student enters the lab and it picks a computer at random. Find the probability. So we have a table here that kind of walks us through. So new computers, there's 40 new PCs, 30 new Macs, which is a total of 70 new computers. Used computers is there 20 PCs, 10 Macs, and 30 total. And there are 60 total PCs, new and used, and 40 total Macs, new and used, and just 100 total altogether. And so this is one of the things I'm going to suggest you always do. When you're given a table like that, you need to go ahead and put in this information right here because they may not have given that. You need to just go ahead and add up the columns and the rows and put that information in there. Okay. You may not use all of it, but it's good to have it available quick and easy. Okay, so let's go through these examples. So this is the probability that if you pick the computer at random, it is new. So this means out of every computer in the lab, that's 100, there are 70 that are new. So 70 over 100. And of course, you always reduce your fractions. So the probability is 7 over 10, 7 out of 10. Okay. The next example here is what's the chances of picking a computer, okay, is a PC. So again, we're talking about all of the computers in the entire lab. So that's out of 100. Now, how many of those are a PC? So since we've done this situation, added it up for us, we got 60. So 60 out of 100 reduces to 3/5 because we always reduce our fractions, right? So those are a couple of things. And both of those were like picking any computer out of the entire lab. Um, what if we said, hey, I already know that I'm going to use a PC. What's the chances I get a new one? Or something along that way. Well, that's going to change your denominator. Okay, so let's continue to look at some more scenarios. All right. So we still got these subtotals here that we're using. They're handy for us. We've already gone through the first two scenarios. Now this one says, what's the chances that I pick a new one and it's a PC? So I'll walk into the computer lab and I just pick any one of them. So what's the chances I pick one that's not only new, but it's also a PC? So this word and, right? And so how many of these are a PC and new? Well, 40. And that's where that 40 comes from. Okay. So let's clean that up a little bit now that I'm done marked all over it. Okay, so that's where the 40 is out of 100, which reduces to 2/5. All right. Now, we've got some new symbols that we got to get used to here. It says, given that the computer is new, what is the probability that it is a Mac? So you see this P, Mac, vertical bar, and then new. Good grief. Why am I so dark today? Interesting. Oh, well, slide over here a little bit. Yeah. All right. So, may not be that good looking, but at least you can not have me in the dark so much. Wow. Oh, well. Uh, so, where was it? Okay. So, we got Mac, vertical bar, new. So how do you read that? It says, given that you know it's new, what's the chances it's going to be a Mac? So given that, that is what, so given that, that is what that bar means. Okay. And you always got to put that in. So this right here is going to, the second piece is going to determine your denominator. So given that you know it's new, so how many computers are new? 70. So that's why the 70 is in the denominator. Okay. And so, and when you, and as soon as you say, given that it's new, this is something we already know. We're going to know right off the bat. Would you please just give me just green? Just green. Thank you. All right. So given that it's new, as soon as it says that, that means everything else is gone, right? Okay. Let's make it real clear. So here we go. Given that it's a new computer, that means all the other stuff has gone away and all you have is 40, 30, and 70. Okay. And so it's going to be 30 out of 70. Okay. So I sure have made a mess around here, haven't I? Let me do a little cleanup. All right. So our next example here, it says, given that the computer is used. Okay. So as soon as it says that, that's this piece right here, given that it's used, we're only going to focus on whatever's on that line. So 20, 10, and 30. Those are the only numbers we're worried about. Everything else we're going to completely ignore. Okay. So given that you know it's used, what's the probability that you pick a PC? So there's 20 out of 30. So that's where we get, so that changes the denominator. So when you say, given that, that changes our denominator, changes a lot of things immediately. Okay, so this is a pretty good example. Let's go down to the bottom of this page, and let's look at this situation. Okay, we got a bag that contains some red marbles. Okay, all kinds of marbles with dots and not dots and different colors, and they want us to figure out the probability with these different situations. Okay, well, they didn't make a table for us, but that's okay. Boom, there's a table right there. I'm gonna put me right over here. Okay, so here's the table, and I've already got it started for us. So it says a bag contains 20 red marbles. Okay, so we got 20 red marbles. Oh, that also have a blue dot. Well, good, I got that in the right spot. So red marbles that have a blue dot. Okay, red marbles with a blue dot. All right. Then it says there are 15 red marbles without a dot. So they're red and no dot, so that's a 15 right there. Now, in addition to the bag, there are 30 white marbles. Okay, I'm just going to use black, I guess, because white won't show up on white very well. So in addition, the bag contains 30 white, oh, not marbles, balls, with a blue dot. So white with a blue dot, that's 30. Okay, and then it says 25 white balls without the dot, so that's 25. Okay, and I remember I mentioned to you that you want to go ahead and fill in these totals because they're not going to give them to you a lot of times. So there's your 35, there's 55, and that's 50, and 30, 40. So 50 and 40 make 90. 35 and 55 make 90 as well. So we did good. All right, so let's get this guy going here. So what's the probability that if we picked a random ball out of this bag that you'd get a red? Well, how many reds are there? Well, there are 35 reds. How many total are in our bag? 90. Okay, and of course you would reduce your fraction, which in this case would be 7 over 18. Okay. Now, this next one here says, what's the probability that you pick one that doesn't have a dot at all? Okay, well, how many don't have dots? 40. There's 40 of them that don't have dots. Okay, out of the entire bag. So it's be 40 over 90. So 40 over 90. And then you would, of course, reduce that to 4/9. Okay, and then number 7. Oh, this is one of those that's got that vertical bar in it. Okay, so let me read this to you. It's what's the probability given that you're going to pick, you're going to get one without a dot, that it's going to be red. Okay, so what's the probability you get a red one given that it has a dot? So what this says is this: we know it has a dot, don't we? So what we're going to do is we're going to say has a dot. So that means that's the only thing in consideration as we get to look at it. So what's the probability that we get a red one knowing that it has a dot? So that's going to be 20 out of 50. Okay. So 20 out of 50 there. 20 out of 50, which reduces to 2 over 5. All right. Now, what about number 5? It says and. Okay. So it says, what's the probability that you pick a red ball and it has a dot? Okay. Now, is this out of the entire bag or just out of one part of something? Well, it didn't say given that, did it? So it's talking out of the entire bag. So what we're going to know, we know for sure there's going to be out of 90. Now, how many are red and have a dot? So that looks like 20. And so that'd be 2 over 9. So that's how that would work. Okay. And I think you can work the rest of these here, but that gives you a good start on how this goes. So let's look at another example now. Okay. Well, this guy here, let me move myself out of the way a little bit. The table contains information about 1,205 employees in one business. Find each probability and then round to the nearest tenth of a percent. Okay, round to the nearest tenth of a percent. All right, so we've got to use this table here and answer these questions. So what did Mr. T say that always what you should do first? Yeah, let's do some addition. So I'm going to, through the magic of hitting this button here, boom, there it is. I've already got all that done for us, okay? So we've added up the columns and the rows and got all that in place. So now that we got that, we can start attacking these questions over here. So what's the probability that if you picked a random employee, that person has less than a high school education? So this is out of the entire business, right? So the bottom number is going to be 1,205. Okay, now how many employees have less than a high school education? Okay, so each of those would, and those total up to 107. Okay, 107. So it'd be 107 divided by 1205. Okay, well, that's good. So let's jump over to our calculator now. And so we got 107 divided by 1205. Okay, so it's 0.089. 0.089. 0.089. So that's what it is as a decimal. But it says rounded to the nearest tenth percent. So what they're telling us here is they want us to move this over 2 places and write this as 8.9%. Okay, so you set up your fraction, convert it to a decimal, and then convert your decimal to your percent. Okay, and B, okay, this crazy dishwasher over here is going beep, beep, beep at me because I opened it because I was making too much noise while I was making this video. But that's okay. We can take it. You may not even heard it. All right. So what we at? B? Yeah. All right. By the way, Merry Christmas. When I'm making this video, it's Christmas time. And, you know, that's a great time of year. So we got our employee earns under $20,000. Okay. So this is out of the entire company still, right? And so how many employees out of this entire company earn under $20,000? Well, it's all four of those guys. And so that's 296. Okay. So got 296. Well, let's do this. So 296 out of 1,205. And then you would convert to a decimal, then to a percent. Okay, it's kind of crowded to do this work, but please make sure you do show this work. All right, now see, employee earns over $30,000. Oh, and has less than a high school education. Now, is this just out of one category or the other? No, it's out of the entire company. So it's still 1,205 on our denominator, but our numerator has multiple conditions. So we're looking for employee who earns over 30,000. Okay, so that'd be this column right here, and has less than a high school education. Well, that would be, that'd be a whopping 2, right? Okay. So it's not that you can't earn over $30,000 with less than a high school education. It's just not normal. Okay. Because so you can always pick out somebody. Well, my uncle so and so, and well, that happens, but it's just not all that often. Okay. So, and then now we got an and here, 20,000 and has a high school degree. Oh, now let's go down here to E. This is one of those given that. Okay, given that the employee has only, so given that the employee has only a high school education. Okay, so what does that tell me right off the bat here? Okay, get my highlighter. So that means these are the only numbers that I'm going to take into consideration. Okay, it says given that the employee has only a high school education, that means 112, 98, 14, and 224, the only numbers that have anything to do with what's going to happen. Okay, what's the probability that the employee earns over $30,000? Well, hey, we went up to 14, and so the odds are a little bit better. If you notice, the more education, the odds are, no guarantees in this world, but the odds are a little bit better that you make a little bit money. Okay, a little more money. So 14 out of 224. So 14 over 224. And of course, we got to put some dots there. 14 out of 224. And you would finish that job out. So that gives you a little start on those. Hope you're kind of catching on to the pattern. Just so thinking through, read, and make sure you get your given because that will change your denominator. All right. Got just a couple more here we want to do a little bit with. And so let's move me back up in here. Think there. All right. We got high school students in one school choose their favorite leisure activity. Find each probability and round the nearest tenth of a percent. Okay, so we got sports, hiking, reading, phoning. People who used to just talk on the phone for fun. Wow. And then shopping and then other. That's their leisure activity. And then they got how many females and how many males would be involved in that. Now, in this activity, every single one of them have that vertical bar that means given that. So I'm going to do about 3 of these just to make sure we're on track. And again, need to do some totals. Now I only filled in this section because that's all the part I'm going to need for my examples. Okay, so let's do this first one as an example. It says probability of sports given that they are female. So as soon as it says that, in my mind, given that it's female, I'm saying these are the only numbers that count anymore. As soon as I see this little thing right here that says that's going to affect everything else. Everything on that next row doesn't matter anymore for this problem. So what's the chances that they're going to be sports given that it's female? So that's going to be 39 over 334. So let me get that highlight going so I can have it clear for the next round. So we said, what in the world? Hit that wrong button, didn't I? Let's try this again. Okay. So we said it was 39 out of 334. Okay. And of course, you would always reduce that fraction if you can. All right. And since it said round to the nearest tenth of percent, so we're going to have to change that into a decimal. So 39 over 334. So 39 divided by 334. So 0.117. So that's 0.117. And then that would turn into 11.7%. Okay. Now B, what about B here? Okay. This is exactly the same two things, but now they've reversed it. They said, now, given that you know that they're into sports, what's the chances that they're female? Okay, so now what are we doing? We're only dealing with 39, 67, and 106 because we're given that they're into sports. So that means we're going to have 39 still, but this time it's going to be out of 106 because it's given that sports. So both of those are sports and females, but it depends on where you start. That affects your denominator, okay? And so then you would do 39 divided by 106, take the decimal, and then to a percent. Okay, so we got to finish that out. All right, one more, and I'm going to leave the rest of these to y'all. So this is reading given that it's a male. So that means what? Only the second row is what we're talking about. So that means our denominator, this guy here, is going to be 3. 362. And reading. How many guys enjoy reading out of this group? 76. Okay. And again, you would finish that out as well. All right. So that gives you a lot of practice working with that, given that, and you can see how it changes depending on which one comes first. So that's important to get that straight. Okay, then one last one here. All right, so this is not necessarily using these numbers up here. This is just in general, okay? All right, the senior class is 55% female. Well, that's obviously not what's going on here, right? Because there's actually in this one less females. So we're just going to say it's 55% female. And 32% are females who play a competitive sport. So out of the entire senior class, 55% of them are seniors. And of that group, 32% like to play competitive sports. So find the probability that the student plays a competitive sport given that the student is female. So this is just simply 0.55 times 0.32. And then you get that and then change that to a percent. Voila. Okay, so this is a little bit of an introduction and try to give you a little bit of help on how to walk through doing finding conditional probability using these two-way tables. Doing this without the tables is much harder using the formulas, which we can do that as well. But these tables really do help us be able to visualize and figure this out very easily. So as always, hope that's helpful, and y'all have a great day.